In this video, we're going to take a basic look at the introduction to differential equations. When we use the term differential equation, what we're referring to is some equation that involves an unknown function, which we'll call y or f of x, and one or more of the derivatives of that function. For a simple example, let's consider the equation y prime equals 3x squared. This is an example of a differential equation because on the left-hand side of the equation, we have the derivative of some unknown function y. And on the right side, we have an expression involving the variable x. And so this particular equation is saying that we have a function y whose derivative, y prime, is equal to 3x squared. This differential equation is rather simple, and it's pretty easy to see that y equal x cubed would be a solution to this particular equation. This function, y equal x cubed, if we took its derivative, we would get indeed 3x squared, and that would satisfy our equation on the left. But it is not the only solution. For example, y equal x cubed plus 5 would also be a solution. If we differentiate y equal x cubed plus 5, we will also get 3x squared, and this equation or this function would satisfy our differential equation. And in fact, along the same lines, if we take y equal x cubed plus any constant c, any real number c, we know the derivative of a real number or a constant is 0, and so the derivative of this function would also be 3x squared, and this would be a solution to our differential equation as well. Since there are infinitely many real numbers or infinitely many values for c, this particular differential equation has infinitely many solutions. The first step in understanding solutions to differential equations is to look at how to determine if a given function is a solution to a differential equation. So in this example, we're being asked to determine if the function y equals e to the negative 3x plus 2x plus 3 is a solution to the differential equation y prime plus 3y equals 6x plus 11. Our strategy here is going to be to substitute the function y into the left-hand side of our differential equation and simplify. And we will either obtain 6x plus 11, in which case our function will be a solution, or we'll obtain something that's not equal to 6x plus 11, in which case our function will not be a solution. So in order to do this, we need to compute y prime plus 3y, and so we can do this in a couple different steps. We'll first compute y prime. This is just the derivative of our given function here, and we'll do that term by term. So we start with the derivative of e to the negative 3x. So we know the derivative of an exponential is the function itself, so e to the negative 3x. But then by the chain rule, we have to multiply by the derivative of the exponent, negative 3x, which is negative 3. So we end up, for the first term, with a derivative of negative 3e to the negative 3x. The next term is plus 2x. The derivative of that is 2. And of course, the derivative of a constant 3 is equal to 0. And so we end up with a derivative y prime equals negative 3e to the negative 3x plus 2. Our next step is to compute y prime plus 3y, which is the left-hand side of our given differential equation. Well, we've just found y prime, so that'll be negative 3e to the negative 3x plus 2. And we want to add to that 3 times y, which was our original function, e to the negative 3x plus 2x plus 3. Now we're just going to distribute that 3 in the second part of our expression. So we have 3e to the negative 3x plus 2 plus 3e to the negative 3x plus 6x plus 9. Here we have some cancellation. The negative 3e to the negative 3x and the positive 3e to the negative 3x will actually cancel out. And what is left is simply 6x And then we have a constant of plus 2 plus 9, which is plus 11. Right, so our expression y prime plus 3y, when our function is substituted in, yields 6x plus 11. And when we go to look at our differential equation, that is exactly the right-hand side here. And so what we've shown is that if we substitute this function, y equal e to the negative 3x plus 2x plus 3, into our differential equation, we end up with two identical sides, and therefore this is indeed a solution to our given differential equation. If we had not obtained 6x plus 11, but rather some other expression that's clearly different from 6x plus 11, then we would have concluded that our function is not a solution to our differential equation.